Seventh grade students are next going to continue in their notes packet. So this happens after you've assembled your 4x4 puzzle or got as far as you could with your order of operations. And next we need to look at applying integer rules to our order of operations. So that's kind of our next task at hand. You can kind of not worry about the numbers that I have on here. I just took these off a worksheet that I thought would kind of be helpful for us. So number 25 is the first one we'll look at. And I'm just going to copy it down so that I have lots of space, lots of room to write here. That -1 is in parentheses, so I copy down everything just the way I see it. And now I really need to think about PEMDAS. Or GEMDAS, depending on which one you prefer to memorize. But please excuse my dear Aunt Sally, seems to be what I hear most of my 6th graders come in remembering. So are there any parentheses? The answer is yes. And in fact, here it might be important to change a minus to a plus, change the sign of next, so we can kind of apply our rule. In parentheses, we are going to take 2 plus a -6. Different sign subtract, keep the sign of the farther number. Looks like I'll get a -4 happening here. So I'm going to bring everything else down just the way it was. And I do think it's a good idea to keep this bracket idea happening so that you can see which piece we've taken care of. This is to the second power. It doesn't really need to be in parentheses unless I get a negative happening in here. And I want to make sure that I take that negative from my answer, my addition or my subtraction, depending on how you think of this, that happened in the middle. And that whole thing, that whole difference is going to be squared in a minute. We'll bring everything else down. Remember, you're expected to show line by line work. Well, are there any other parentheses that I can deal with? The answer would be no, because inside I only see one integer. Inside there's only one integer, no operation to do. So parentheses is set. How about exponents? Yep, we have this exponent here, and you really need to keep those parentheses on because this right here would mean -4 times itself, or -4 to the second power. If this was written differently, so I'm just thinking over here because you're going to see this somewhere else on your worksheet today. If it said -4 to the second power, that would really mean the opposite of 4 times 4. Well, 4 times 4 is 16, but the opposite of that is a -16. Okay, what this one says, this is different. This says I want -4, the whole quantity of that integer is squared. So it really means I'm taking -4 times -4. Well, what is a negative times a negative? They seem to get along. They both hate Brussels sprouts. So 4 times 4 is 16, and it stays positive again because my signs agreed. This is really the one that we're looking at right now. So I need to make sure that you remember the difference between those. So I'm going to take this exponent and simplify. This -4 to the second power really gets me a result of 16. Bring everything else down the way you see it. Are there other exponents? The answer is no. Is there multiplication to deal with or division in order from left to right? The answer is yes. As you move along, the first thing I see here is a multiplication, so that's what we better do first. What's -1 times 16? Well, 1 times 16 is 16, but those signs don't get along. That should be a -16, and we bring everything else down in our line by line work. Is there more multiplication or division in order from left to right? Sure is. Next I see a division. It's the very first operation to choose from. In order from left to right. -16 divided by 8. Well, 16 divided by 8 is 2, but this is a -16. These signs don't get along. They disagree. So it's a -2. Bring everything else down just the way you see it. We're not done yet because I notice multiplication and division are buddies. They go in order from left to right until they're all complete. Well, next I see a multiplication coming right here. So I could take care of 3 times 4, which gets us 12. And we bring everything else down exactly the way we see it. Multiplication, division, done. How about addition, subtraction? In order from left to right. Well, we'll add first. I have a -2 and a +8. Well, the rule I've remembered is different signs subtract. 8 take away 2 is 6. But we need to keep the sign of the farther number. Well, good. The positives are farther. This is a +6. And we'll bring down a take away 12 at the end. Hold up. I'm trying to take away more than what I have. This would be a good time to add the opposite, or change a minus to a plus, change the sign of next. What is a +6 plus a -12? Well, different signs subtract. 12 take away 6 is 6. 6, but keep the sign of the farther number. There are more negatives than positives. This should be a -6. That's our answer for number 25. And if you notice, we made some beautiful pizza. This inverted triangle looks awesome because we did line by line work. Let's take a look at a shorter one here, number 26. See if we can squeeze this down here for you. And I wonder if we should get to some focusing too. So 26 says 5 take away a -3 squared minus 6. All right, thinking of PEMDAS again, or GEMDAS, depending on which one you prefer. They really will accomplish the same task in order of operations. Are there parentheses? The answer is yes, but look inside. It's only an integer. They're just holding an integer in here for some reason. Nothing I can do inside. How about exponents? The answer is yes. And remember that this whole integer is being squared. Not just the 3. That -3 is being housed together and squared. So off to the side here, I might show you -3 in parentheses squared, meaning the base is -3. If I were to show expanded form, that would be -3 times -3. I know 3 times 3 is 9, but what about the signs? Do they get along? The answer is yes. It's a +9. Let's do a rewrite over here then. We'll bring down that 9, and we will bring everything else that has not changed down with it. Oh, we have a couple of subtractions, but to be honest with you, I took care of exponents here. I'm looking for multiplication, division, which I don't have. Addition, subtraction. Could I change these so that they were additions? Could we use our integer rules here? Change a minus to a plus, change a sign of next. Could I do it again? Change a minus to a plus, change a sign of next. I could. And now I could really just work in order from left to right, or I could recognize that addition is commutative. But let's try moving in order from left to right here. Different sign, subtract. 9 take away 5 is 4. Positive or negative? Well, who has the farther number? The negative wins. And plus a -6. Last step, we have some addition, but we're adding negatives. A negative plus a negative is still a negative. Looks like 4 plus 6 is 10, and same sign, add and keep. The answer here is -10. Looks like we should be heading in the right direction with these. You want to do some checking as you go to make sure that you are showing this line by line work. If it helps you to write the rule off to the side, like the first line was exponents, the next line was an addition, or you could have called it a subtraction or different sign, subtract. And the next line was same sign, add and keep, or you might write addition again. If it helps you to show those steps along the way, you're absolutely welcome to do so. I think the other ones up here really look similar, so I'm going to trust that you're able to do those for us. Number 27 in a minute should get you an answer of -2. And number 28, I don't have that on my answer key, so I might come back to you in just a second once I do a little bit of figuring out. So I just worked on number 28 while you were away, hopefully working on your own, and I found an answer of 20. This one was a little bit tricky because there were so many subtractions happening in here. So what I decided to do after I simplified my multiplication, I changed a minus to a plus, change the sign of next. And I did it again. Change a minus to a plus, change the sign of next. As long as you're consistent and you do that all the way through, it should work out fine for you that you end up with a bunch of additions to handle on your way down. And if you notice, line by line work will tell you that you have a nice inverted triangle. Maybe you call it a funnel, maybe you call it a cone. I like to call it pizza. So grand finale for a joke. You made it through my note taking. Knock knock. Surely. Surely you're not afraid of monsters, are you? With that, it's time for you to start your assignment. It looks something along this line. Integer order of operations worksheet. I think today we're just going to shoot for, how about the odds? So just the odds, just 1, 3, 5, 7. Continue with the odds till you get all the way to 23. There is not enough room on here, so I have to tell you, lined paper is required. Lined paper is a must. The other thing I need to warn you about, pizza method, okay? So make sure that I can see this type of work. And I just put a question mark in here. If you're using pizza, you're good to go. If you're not, there's going to be a problem and you're going to have to redo your work. Notice that in our work each time, kind of a friendly reminder, I don't have any equal signs. I don't show any equal signs, because if I do, I end up being a mathematical liar most often. Over here, even in this really long problem, number 25, no equal signs. I just simplify one step at a time all the way down. No equal signs needed. That means that this line is equal to the next line is equal to the next line in value. That's really what I want to see from you. So be careful. No long strings with equal signs in them. All right? So line paper, and again, line by line work so that we see this inverted triangle, also known as pizza.